Somewhere in your first 2 or 3 years of life, something happened to you that you will never remember, not because it wasn't important. Some of it was the most important stretch of your entire existence. You learned to walk. You heard your parents' voices for the first time as actual words instead of noise. You had a favorite blanket, a favorite face, a first fear, a first joy, and all of it is gone. Not hidden somewhere waiting to be unlocked. Gone. Deleted. Unrecoverable. As if it never happened at all. This is not something wrong with you. This is not a personal failure of memory. This happens to every single human being who has ever lived, without exception, and for most of the last century. Nobody could explain why. Let's start with the phenomenon itself, because the scale of it is genuinely strange once you sit with it. Ask any adult for their earliest memory, and the answer almost never goes below the age of 3. Most people land somewhere between 3.5 and 4. Whatever came before that age, the first 1,000 or so days of a human life, is simply unavailable. Scientists call this infantile amnesia, and it was first named over a century ago by Sigmund Freud, who noticed the pattern in his patients and assumed it was some kind of psychological repression. Memories buried because they were too disturbing to keep around. Freud was wrong about the mechanism, but he was right that something real and universal was happening, and it took almost 100 years of neuroscience to figure out what. Here's what makes this genuinely bizarre. It's not that babies can't form memories. They can. A 6-month-old can recognize their mother's face, remember a toy they played with days earlier, and show clear signs of learning and retention. Babies are not blank recorders waiting for memory to switch on. Something more specific is happening. The memories are forming, and then they are being actively wiped out. This isn't a storage problem, it's a deletion problem. And once researchers reframed the question that way, from why can't babies remember to why does the brain erase what babies do remember, the whole investigation changed direction. The first real clue came from an unlikely place, a structure buried deep in the brain called the hippocampus. If you've ever studied memory even casually, you've heard of it. It's the region responsible for converting short-term experience into long-term, retrievable memory. Without it functioning as intended, you cannot form new lasting memories at all. This is what happened to the famous patient known as H.M. in the 1950s, who had his hippocampus surgically removed to treat severe epilepsy and afterward lived every day as a new day, unable to retain anything for longer than about 20 seconds. The hippocampus is not optional, it is the machine that writes memory into permanence. And here is the critical detail. In infants, that machine is still under construction. The hippocampus is one of the slowest developing structures in the entire human brain. It is nowhere near mature at birth, and it keeps developing new neurons at an extraordinary rate well into early childhood, a process called neurogenesis. Most brain regions slow their neuron production dramatically after infancy. The hippocampus keeps going, adding fresh cells to its circuitry for years. For a long time, neuroscientists assumed this was simply part of normal brain growth, the hippocampus filling itself in like any other developing organ. But in 2014, a study out of the University of Toronto, led by neuroscientists Paul Franklin and Sheena Jocelyn, published in the journal Science, found something that reframed the entire picture. High rates of neurogenesis don't just build the hippocampus, they actively destabilize memories that are already stored there. Think about what that means for a second. The very process responsible for growing your memory-forming machinery is, at the same time, tearing apart the memories that machinery has already made. Franklin and Jocelyn worked with mice, training infant mice to associate a specific environment with a mild stimulus, then testing whether they retained that association days later. Adult mice retained the memory. Infant mice, whose hippocampi were still undergoing rapid neurogenesis, did not. The memory had been formed. It had simply been overwritten by the flood of new neurons still being installed into the circuit. Then they ran the reverse experiment. They artificially slowed neurogenesis in infant mice, and the forgetting stopped. The baby mice held onto memories the way adult mice do. They also sped up neurogenesis in adult mice, and adult mice that should have retained memory started forgetting like infants. The mechanism wasn't a coincidence, it was a direct, controllable cause. Your earliest memories aren't fading with time the way an old memory eventually might. They're being physically dismantled by the same growth spurt that is busy building the very structure that will, years later, let you remember everything else for the rest of your life. But this is where it gets more interesting, because if it were only about brain immaturity, you'd expect infantile amnesia to simply lift the moment the hippocampus finishes developing, like a light switching on. That's not what happens. The boundary is much messier and much more human than a simple biological cutoff. And this is where a Canadian psychologist named Carol Peterson spent decades doing some of the most patient, unglamorous, and quietly revealing research in the entire field. Peterson, at Memorial University of Newfoundland, ran long-term studies asking young children to describe their earliest memories, then going back to the same children years later and asking again. What she found broke the simple version of the story completely. Very young children, ages 4, 5, 6, could describe memories from before age 3 in real detail, specific, coherent, plausible memories, later confirmed by parents as accurate. But when Peterson followed up with those same children years afterward, many of those early memories had vanished. Not faded, vanished, replaced by nothing, as if never recorded. The memory had clearly existed. It had clearly been accessible at one point, and then it was gone anyway. Sometimes years after the hippocampus should have already been mature enough to hold onto it permanently. This told researchers something crucial. Infantile amnesia isn't a single event that happens once around age 3 and then stops. It's an ongoing, rolling process that continues to prune memory well into middle childhood. And the boundary of earliest memory that most adults report, that hazy line around 3.5, is actually the last surviving edge of a much larger wave of forgetting that swept through childhood memory for years afterward. Somewhere around age 7, this process finally slows down and stabilizes, and whatever memories survive past that point tend to stay for good, which means the story isn't really babies can't remember. It's closer to children are constantly forming memories that get systematically deleted. For years, until the deletion process itself eventually runs out of momentum. So why would a developing brain do this on purpose? Why would evolution build a system that generates memory and then spends years tearing most of it back down? This is where the explanation stops being purely mechanical and becomes something closer to a design trade-off. And it comes down to a concept called the stability-plasticity dilemma. A brain that's rapidly building new neural architecture, learning language, motor coordination, spatial navigation, social recognition, essentially assembling itself from scratch, needs enormous flexibility. New neurons integrating into the hippocampus at a rapid pace is exactly what lets an infant's brain absorb an almost incomprehensible amount of new information in a short window. But that same flexibility is corrosive to long-term stability. A memory circuit that's constantly being rewired to accommodate new learning cannot simultaneously function as a stable, permanent archive. You can have a system optimized for rapid construction, or a system optimized for durable storage. During the years when a brain is under the heaviest construction load of its entire life, it prioritizes the construction. There's a second layer to this that researchers have only more recently connected, and it has to do with language and self-concept rather than pure biology. A developmental psychologist named Chi Wang, at Cornell, has spent years studying how autobiographical memory, the kind of memory tied to a coherent sense of me, at a particular time, having a particular experience, depends heavily on something infants simply don't have yet, a working sense of self as a continuous character across time, and the language to narrate that character's experiences. Autobiographical memory isn't just information storage, it's information storage organized around a story, and a baby doesn't yet have a narrator. Wang's research also found something that pushes back against the idea that this is purely a hardware limitation, comparing children raised in cultures with different styles of parent-child conversation. Particularly comparing American families, who tend to engage in detailed, elaborative reminiscing with young children, discussing past events in rich narrative detail, against East Asian families, who traditionally engage in more brief, fact-focused conversation about the past. Wang found measurable differences in both the density and the earliest boundary of childhood memories those children could report as adults. Children raised with more elaborative reminiscing tended to report earlier and more detailed first memories. This suggested that infantile amnesia isn't purely a neurological deadline. It's also, in part, about whether a young brain is given the narrative scaffolding, the practice of turning raw experience into a storyable memory. Before the hippocampus's window for stability closes, the biology sets the ceiling. The environment determines how close to that ceiling a child actually gets. Put those two mechanisms together and you get a much stranger and more complete picture than babies just can't remember yet. Your brain during infancy is simultaneously building the machine that will eventually hold your memories permanently, flooding that same machine with new neurons that destabilize anything already stored there, and lacking the narrative self-structure needed to convert raw sensory experience into the kind of story-shaped memory that survives long-term. 3 separate systems. each with its own timeline, each pulling in a slightly different direction, all converging on the same result. Almost nothing from your first 3 years makes it out alive. And here's the detail that tends to unsettle people the most once they hear it. This doesn't mean those early experiences had no effect on you. This is the part that's easy to misunderstand. Because you can't remember it sounds like it didn't matter. The opposite may be closer to the truth. There's a growing body of research on what's sometimes called implicit or procedural memory, the kind of learning that doesn't require conscious recall to shape behavior. Attachment patterns formed in infancy, the emotional responses your body learned before you had language to describe them, the sense of whether the world is generally safe or generally unpredictable. These can be laid down during the exact window your explicit, narratable memory is being wiped clean. You won't remember the specific moments that built those patterns, but the patterns themselves can persist for life, running in the background, shaping how you react to things decades later, completely disconnected from any retrievable memory of where they came from. In a strange way, the years you remember nothing about may be quietly running some of the deepest wiring you'll ever carry. There's also a wrinkle in all of this that researchers still argue about, and it's worth being honest about rather than pretending the science is fully settled. Some of what people report as early memories from before the infantile amnesia boundary aren't actually memories at all, in the sense of a stored recording of a lived moment. They're reconstructions, built later, out of photographs, family stories told and retold, and the ordinary human habit of stitching disconnected fragments into something that feels like a continuous memory. Peterson's follow-up studies caught exactly this happening. Children would confidently describe an early memory that turned out, on closer questioning, to be something they'd heard described so many times that it had been absorbed and reformatted as a personal recollection, even though the actual lived experience behind it was gone. This is a broader feature of memory generally, not unique to infancy, but it matters here because it means some of what feels like a triumphant exception to infantile amnesia. Someone who insists they remember being 2 years old is very often the brain doing what it does at every age, filling gaps with plausible material and presenting the result with total confidence. Which brings the whole picture back to something worth sitting with: the years that made you, that shaped your attachments, your instincts, your first sense of who was safe and who wasn't, are the years you'll never be able to walk back into, not because they were unimportant, but because the very process that built the rest of your mind required tearing that specific record down to make room. Every adult alive is, in this narrow but very real sense, running on formative years they cannot personally verify, trusting that whatever happened during that blank stretch shaped them well, with no way to check the receipts. The brain that gave you the ability to remember anything at all had to first sacrifice its record of how it built itself.